Alright guys, whoa, that's me in the corner. I wear glasses sometimes. You've never seen that before, have you? So, this is appropriate. It's negative, like -8 Sunday night into Monday right now while I'm recording this. It's cold. And this is a graph that represents temperature, as you can see here, temperature in degrees Fahrenheit on your paper, versus weeks, time. After the spring equinox. I'm not exactly sure when the spring equinox is. I don't even know what the spring equinox is, but I'm pretty sure it's the day after my birthday, day before my birthday. I think it's March 21st is the spring equinox, which would kind of make sense. So if this is like March 21st, I think this is like March 20th. As it goes in this flow, this is called a sine wave or a sine curve. It's related to trigonometry, which we'll see in a few years. So what does T of W represent? It means temperature depends on W, W being the weeks on here. So I'm using, this is function notation with actually some context, where there's actually not time, but temperature versus the amount of weeks past the spring equinox. In other words, time fluctuates depending on what week you are. Now, this is like recorded data. Maybe these are average temperatures for a day. Obviously, you could have extremes that are higher or lower. That's why it's not a continuous curve here. These are just maybe average temperatures for a given day at a given time in Vermont or somewhere. I don't know. So answer this in your own words. There's going to be various answers you can have for that. And you might want to pause now if you haven't had a chance to do that. T of 10. I don't know if you have any idea what that means. I'm going to throw an answer up here and see if it makes any sense. The answer to that is 68 degrees. Take a look at the graph and figure out how the heck I got that. Think about that for 30 seconds. How the heck did I get 68 degrees? Well, we're talking function notation, so I just want you to be familiar with this type of writing here. This is not T times 10. This is the temperature when W is 10. I don't know why I'm using this thing. Where's my pencil? Temperature when the weeks are 10. So you just go to 10 weeks and you just go up and you figure out what that temperature is. Oops, sorry about that. And you go up to here and then you work your way across and just estimate it. You're not going to get right on, but it's it's a little less than 70 probably. Maybe it's right on 70. Maybe it's 69. I don't know. We're just kind of using this graph to sort of estimate values. You don't have given data. You probably prefer to look at the picture in this situation. So that should make sense of how to find the T of 30. Find the temperature when the weeks are 30. In other words, the temperature depends on week 30, how far you are from spring. Obviously, as we get further... Oh, wait, does this make sense? Yeah. Further from spring, the temperature goes up. I wonder what time of the year this is. Probably the middle of summer. And then as we get further going the other direction, it gets colder, 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 and colder until we're right around this time of year. This is probably December, late December, early January, right around now. Freaking cold out. Temperature at 30 degrees, 30 weeks, somewhere over here. You maybe work your way across, somewhere between 20 and 30. I would estimate around 22 degrees. If you're off by 1 or 2, maybe you're more accurate than I am. That's okay. We're estimating this thing. See, we'll attend to precision some other time. Third one, find W. This is switched around here, and usually you'd see. Yeah, I guess that's all right the way it's written. Find a W. Find a week such that the temperature is 10 degrees. Completely different than how it's written here. So you go to your 10 degrees here and you work your way across and you find when does it equal 10 degrees. Bingo, right at the bottom of that curve. This is definitely not Vermont. If the bottom out temperature is only 10 degrees, I wish it was only 10 degrees. You're looking at somewhere around week 40, around maybe week 38, 39, 41, somewhere in that range. Somewhere around there. So I'm approximating that. So this is just the other way around. This is asking you to find the temperature when weeks are 10. This is asking you to find W when the temperature is equal to 10. And the last one, of course, is a lot like the first one. Describe this function T of W in words. You can do that a lot of different ways. The temperature depends on what week you are. The temperature fluctuates. It has a maximum temperature here and a minimum temperature down here. A lot of different ways you can answer that. And of course, I mentioned this being probably the middle of winter, 40 weeks past March. And I'm trying to get this word dependent here so you can think about dependent and independent variables. Time will go on independent of everything else. Time's going to go on. Sorry, guys. It is the temperature that depends on the time of the year you are. You know, in general, usually when it's summertime, it's warmer. Usually when it's wintertime, it's colder. I'm just trying to get this independent, dependent variable thing into your brain here with some context. Now, if you've been to the fair, this might be relative to you. You didn't have these things on your paper, the labels for the X and Y axis. This is fear. The Y axis is fear. So there's positive fear, there's negative fear. I don't know what the heck negative fear even means. That's why there's nothing down here. This is time or distance. So there's somebody gets on this fair ride, and they go around the loop, and they get down to here. This graph does relate to some circle equations you've seen before. I could ask you, what's the circumference of a circle? Think about that before you get too far into any of these questions. What is the circumference of a circle? There's a formula for it. Circumference of a circle. And don't say pi r squared. It's the other one with pi in it. And hopefully you go, oh yeah, it's 2 pi r. 2 pi r is the circumference of a circle. In other words, when you go around a circle, this is something that's related to a lot of upper level math. You're going to need to know it later. All the way around a circle is 2 pi r. So halfway around a circle would just be pi r, which is why I've got this. If you look at this curve, he's going up and up and up and up and up and back down here. This right here is 2 pi. And you might say, what do you mean 2 pi? I mean, take pi and multiply it by 2. Take 3.14 and multiply it by 2, and what do you get? 6.28. That right there is the end of the ride, 6.28. That's when they're back down on the ground. So try to answer these 3 questions. I've given you some information there. Try to answer this in terms of some words. Try to answer this in terms of a value, and the same thing with this last one. And I'll be back again in the last part of this thing, hopefully the last part of this thing, once you've got some answers down there.